The James Webb Telescope is about to make some incredible discoveries. There will never be another one quite like it, the James Webb Space Telescope. This multi-billion-dollar project, which includes the world's largest telescope, started operating 1.5 months after being launched with great trepidation just before Christmas. A telescope constructed to view back 14 billion years to the beginning of the universe's history when the first stars were forming. Webb's telescope will uncover the mysteries of the cosmos with its vast scope. As a result, it must work flawlessly in space. All eyes are now on the first discovery of this marvel, much like its flawless launch and unfolding as a one-stop shop for the latest in space news. After the successful launch of the James Webb Space Telescope from the Arianespace ELA-3 launch complex at Europe's spaceport near Kourou, French Guiana, on Christmas Day, the scientists were nervous about the telescope's conception to its launch. Although many people felt they had completed the most challenging aspect of the project, they had only just begun. When the telescope began its 29-day space origami project, the evenings of insomnia began. According to NASA's Goddard Space Flight Center's Webb project manager Bill Ox, the first thing he learned in the company 40 years ago was to avoid orbital deployments, but Webb cannot escape it. Some of the most challenging deployment sequences have ever been attempted by Webb. These people knew exactly what they were doing and what it would take to make their creations work in orbit. Once the telescope has cooled down and calibrated its mirrors and equipment, it will begin to detect the first light, which will be another critical challenge for the scientists. When the observatory and its numerous equipment detect starlight, it is known as first light, which is significant for any telescope. The telescope can be aligned for up to a month at a time with the help of these observers. HG 84406 was the star that gave Webb its first light. Located 241 light-years away in the constellation America's Significant, the Big Bear has a sun-like appearance. It is not true that Webb has begun capturing images and launching into a new phase of space exploration. Webb's mission control team will use these photos to position the 18 golden segments of the telescope's 21-foot wide, 6.5-meter primary mirror not for scientific research. These photographs aren't what we expected, but they're precisely what NASA predicted. The telescope will be able to fine-tune the segments over time to capture the image's details better. NASA's Webb Telescope tweeted the first starlight detected by our NORCam equipment, first of several phases to collect pictures that are first focused and utilized to fine-tune the optics of the NASA Webb Telescope gradually. Although there are bigger targets in the sky for the JWST's initial light, HD 84406 was picked by NASA as a calibration target because of its isolated location in the sky. Calibrating its critical sense, it will lead to high-quality space photos. Calibration will take time too, just like every other telescope component. Webb's mirror is 273 square feet, which is 25 square meters, in size, but its segment style, which comprises 18 distinct honeycomb-shaped mirrors that will be one giant sunflower, is the real reason. Mather, a Nobel laureate and astrophysicist who works at the Goddard Space Flight Center in Greenbelt, Maryland, said that we need to find the images that all those 18 different hexagons are making, then figure out which one is which, and start sending commands to the tiny motors that move the viewers around to get them in the right place. When Hubble's precursor James Webb was calibrated 30 years ago, it was nothing like what we see with James Webb shortly. Even though James Webb will take some time, Hubble's primary mirror is most trustworthy than Hubble's Ritchie discretion reflector, with a surface area of just 48 square feet, which is 4.5 square meters. Even though the Hubble was designed in the 1980s, a lot has changed since then. To rectify an optical imperfection, Hubble experienced a difficulty with one of its hyperbolic mirrors, necessitating a servicing trip to Webb. This will occur over the next 3 months when NASA moves each of the 18 gold-coated beryllium panels into place. At this step of the segment imaging identification process, NASA says the early engineering imagery produced knits together over 1,000 photos to make 18 blurry renditions of a single star. Webb's mirror segments will be aligned into a single precise system, using this as a starting point. Once this is complete, Webb will be ready to begin its mission of peering more profound into the universe. As the James Webb is built to work in the mid-infrared, any misdirected heat may disrupt those observations, and the massive telescope has to cool down. As a result, it must be kept cold. To study the first stars of the cosmos, Webb's equipment, mainly the NRI cam, will function at shallow temperatures. This is because infrared radiation is essentially heat, and the Webb must be as cold as possible to minimize interference. As the name indicates, Webb's massive sun shield blocks direct sunlight and sunlight reflected from the Earth and the Moon. Radiating heat into deep space, the sun shield's cold side passively cools and cools the surrounding environment. This will continue until a telescope and the 3 near-infrared and near sensors reach a steady-state temperature. The milliwatts of energy entering through the sun shield plus heat generated by the equipment's electronics balance heat loss into space. According to the Space Agency, the primary mirror and near equipment will drop to below 50 kelvins, negative 370 degrees Fahrenheit, and they will reach roughly 40 kelvins, negative 380 degrees Fahrenheit for the primary mirror. Lower temperatures are required for MIRI, Webb's mid-infrared device. In addition to passive cooling, near-infrared instruments will additionally chill MIRI using a closed-cycle gaseous helium cryocooler or refrigerator to temperatures below 7 kelvins. It was necessary to use heaters early in the cooling process to prevent water ice from forming on the optical surfaces of the instruments. But that is now over, and the detectors and equipment are cooling nicely. Keeping an infrared telescope cool is critical to its performance and outstanding research. It must be freezing for the Webb's detectors to pick up details in the galaxies, exoplanets, and other objects it is studying. According to mathematicians, individual photons are beginning to register in the telescope detectors. He indicated he had no photographs to show you yet, but he hoped to have some shortly. Webb's first scientific images will be made available to the public in late June or early July. While Webb's optics specialists rearrange the mirror segments in nanometer-scaled stages to generate a beautifully smooth surface, NIR may continue to look at HD. This work is scheduled to last until the end of April. The different scientific equipment can begin to train their eyes on faraway and nearby objects correctly. Before starting operating, James Webb must go through a lengthy commissioning process. In a pre-launch briefing by Begonius Willa, Webb Instrument Systems engineer at NASA Goddard stated that we would have 6 months of commissioning, a month of deployment, 3 months to align the mirrors, and 2 months calibrating the science instruments. By early April, the GWST will have completed cooling all of the equipment, including MIRI, and will be ready for what everyone has been eagerly awaiting, achieving the mirror's alignment. Webb will begin its exoplanet surveys after completing its 6 months commissioning phase. One such project will look for 11 worlds the size of Earth and Neptune in our solar system, but no such planets exists. To go along with it, we'll see the earliest galaxies with stars that formed from early cosmic dust and gas just a few million years after the Big Bang. The Sun's Lagrange point, which is positioned beyond the Moon's orbit, is being orbited by Webb. For Webb, this location is ideal since it allows him to remain stationary without using too much fuel. The good news is that according to the latest estimations from NASA, the Webb spacecraft still has 20 years of power left. Everything is going according to the plan up to this point. As Mather points out, there hasn't been anything that we haven't been able to work out. Since the massive James Webb Space Telescope can't afford anything to go wrong, we pray that nothing intractable comes up. The James Webb Space Telescope will revolutionize space science, and we will finally get the answers that we've been looking for with the last film in our series on the subject. I appreciate your support and would love to hear your thoughts in the comments area. Until then, have a wonderful day and thanks for tuning in.